Hello grade 11 students. Today I am here to teach you another important geometry lesson, that's chapter 21, Cyclic Quadrilaterals. So you are definitely getting one question for your O-level exam. So try to get the maximum score from learning the correct concepts. So what's a cyclic quadrilateral? Cyclic quadrilateral is a quadrilateral with all four vertices on the circle. So we'll take one point here, A, B, C, D here. So all vertices on the same circle. Then when we connect this, we get a cyclic quadrilateral. So you need to know what is a cyclic quadrilateral. Quadrilateral with all four vertices on the same circle. So what is quadrilateral means? Four-sided polygon. Now we'll see how we can identify cyclic quadrilaterals. Look at these diagrams. So this is A, B, C, D points on the circle. So what can you say about A, B, C, D quadrilateral? It's a cyclic quadrilateral. A, B, C, D is a cyclic quadrilateral. Look at the next figure. What can you say about this quadrilateral? R point is not on the circle. So this is not a cyclic quadrilateral. So we can write R is not on the circle. So therefore PQRS is not a cyclic quadrilateral. Now look at this diagram. You get a quadrilateral, but M point is not on the circle. So what can you say? This is also not a cyclic quadrilateral. M is not on the circle. Therefore, KLMN is not a cyclic quadrilateral. This one, that's a special quadrilateral. One line is the diameter, passes through the center, but all four vertices on the circle. So therefore ABCD is a cyclic quadrilateral. Look at this diagram. KLMN is a cyclic quadrilateral. Because all 4 points on the circle. Look at this one. Identify the cyclic quadrilateral. You have given extra 2 lines. OD and OC both are radii. But what's the cyclic quadrilateral? ABCD. Now look at this one. You have given 5 points on the circle. Identify all cyclic quadrilaterals. We'll take starting from A. 1, 2, 3, 4. So what's that? A, E, D, C. Take another one starting from A. Do you get another one? A, E, D, B. That's also cyclic quadrilateral. A, E, D, B. Another one. We'll start from E. E, D, C, A. Already done. This one already we have taken. What about another one? E, D, B, A. E, D, B, A also already taken. So we'll start from C. Starting from C, we'll take another color, orange color. C, B, E, D. C, B, E, D. Then C, B, A, D is another one. C, B, A, D is the other one. C, B, A, D. So we have taken all quadrilaterals in this diagram. Now we need to identify what are opposite angles of a cyclic quadrilateral. Look at this one. O is the center and A, B, C, D, 4 vertices on the circle. So what are opposite angles? If you take A angle, opposite to A, C is the other angle. Take B, what's opposite to B? D. So we can write A and C or B and D are opposite angles. This one. What are opposite angles? If you take P, opposite to P is R. P and R. Take Q, Q with S. Q and S are opposite angles. This one. KNML is a cyclic quadrilateral. If you take K angle, K and M. Opposite to this is M. K and M, or L with opposite one is N, are opposite angles. Now we'll try to find out the relationship between opposite angles. We'll take this one as X. Can you remember the theorem that we did related to cyclic quadrilaterals? Here, this is the angle subtended at the center with the QS arc. What's this angle? Angle subtended at the remaining side of the circumference. So what's the relationship between this and this? Grade 10 unit. Can you remember? Theorem related to that. if this is x, angle subtended on the circumference is half of the angle subtended at the center. Or the other way, angle subtended at the center is twice as angle subtended on the circle. So if this is x, this is 2x. So we'll take other way around. What about if this is y? I'll take this color, y. What is this one? That's the angle subtended at the center. If this is y, this becomes 2y. But we know when you take the point O, angle around the point is 360. So this is 2y and 2x is equal to 360 angle around a point. So divide everything by 2. When you divide everything by 2, y plus x is equal to 360 divided by 2, 180. Y plus x is 180. We'll take this one, another cyclic quadrilateral. If this is A, what can you say about this angle? Angle subtended on the circumference here is half of the angle subtended at the center. So if this is A, this is 2A. Other way around, if this is 2B, this is half of that. Now again, what can you say about angle around the point? That's 360. So 2A plus 2B is equal to 360. Divide by 2. A plus B is equal to 180. So what's the important information we got from here? The opposite angles are supplementary. Supplementary means add up to 180. Here also A and B are opposite angles, add up to 180. What about the other opposite angles? We know that the sum of angles in a quadrilateral is 360. So if these two are 180, what about these two? 360 minus 180, you can write the Q angle plus S angle is also 180. Here also you can say A plus B means M and K. L plus N angles also 180 because sum of angles in a quadrilateral. So what's the first theorem related to cyclic quadrilaterals? The opposite angles of a cyclic quadrilateral are supplementary. Supplementary means 180. So we'll try to prove this. So what's data? A, B, C, D is a cyclic quadrilateral and O is the center. So we have to do a construction, connect OB and OD. Now we'll take this angle. We know that this angle BCD is equal to half of, this is equal to half of BOD reflex angle, or other way around. If you want to write down other way around, we can write down BOD reflex angle is equal to double of C angle. I'll take this one as C. Double of C angle. That's 1. Take A now. A and BOD angle. BOD angle is double of A according to the theorem. Angle subtended at the center is twice as the angle subtended on the circumference. So when you add these two, 1 and 2, what happens? BOD plus BOD reflex angle is 2C plus 2A, but we know this one around the point is these two. So these two angles add up to 360 angle at a point. 2C plus 2A, divide this by 2, you get 180 equals C plus A. Then you can say these two add up to 180. So what is B and D? A plus B plus C plus D all add up to 360. What's the reason? Sum of angles in a quadrilateral. Then we know A and C 180. So B plus D is equal to 360 minus 180. You get 180 again. So what's the theorem? Opposite angles of a cyclic quadrilateral are supplementary. That's 180 degrees. What's the converse theorem? Converse theorem means if any two opposite angles of a quadrilateral are supplementary, then the vertices of the quadrilateral are on the circle. So that means it's a cyclic quadrilateral. So what's the converse theorem? If A plus C, A angle plus C angle is 180, or B and D is equal to 180 degrees, we can say ABCD is a cyclic quadrilateral. So no need to know the proof. You can apply straight away. This is a cyclic quadrilateral. Relationship between exterior angle and the interior opposite angle. Exterior. How can we get exterior angle? By extending one side of a cyclic quadrilateral. So here this one BC produced up to E. BC produced up to E. So where's the exterior angle? Exterior angle is here. This angle is called the exterior angle. DCE. DCE is the exterior angle. So how can we identify the interior opposite angle? This is the opposite angle. Interior. So next to that is also an interior angle. But we want opposite angle. That means opposite to this one. So which one is that? This angle. So we can write A angle is this is exterior angle. So what's the opposite interior angle? A angle. A angle is the opposite interior. Now here, identify the exterior and the opposite interior angle. PQ produced up to T. PQ produced up to T. So what's the exterior angle? This angle is the exterior angle. TQR. TQR is the exterior angle. And what's the interior opposite angle? Interior opposite angle is S here. In this one, what's the exterior angle? This angle, SNM. SNM is the exterior angle. What's the opposite, interior opposite angle? Opposite to this one, this angle. L angle is the interior opposite angle. In this one, two lines are there, produced PS line as well as RQ line. So you get two exterior angles. This one, when you take PS produced, you get this exterior angle TSR. Exterior angle. What's the interior opposite to that one? Interior opposite to that one is Q. If we take this one as the exterior angle, this one, PQU, PQU angle. What's the interior opposite angle to that? Interior opposite angle to that is this angle. So here we can't actually write S there. So we have to write properly PSR is the PSR. PSR is the interior opposite angle. This is exterior. PQU. PQU is exterior. Then this becomes the interior opposite angle. Now we'll try to find out the relationship between exterior angle and interior opposite angle. In this case, what is exterior angle? R is the exterior angle. R exterior angle. And Q is the interior opposite angle. Now we'll try to find out the relationship. We know from the previous theorem, opposite angles of a cyclic quadrilateral are supplementary. So Q and P are supplementary. P plus Q is 180 according to the theorem. But what can you say about these two angles, P and R? That's a straight angle. P plus R is 180, straight angle. So what can you say about these two? Both are equal, 180. So we can equate the left hand side. 1 equals 2. P plus Q equals P plus R subtract P from both sides. This one get cancelled out. We get Q is equal to R. This angle is equal to this angle. We'll take this example also. We know x plus y is equal to 180 according to the theorem. In a cyclic quadrilateral, the opposite angles are supplementary according to theorem. And we know x plus c is also 180 straight angle. From these two, when you equate, these two are equal. X plus y equals x plus z. Take x from both sides, you get y equals z. So this angle is equal to this angle. Let's take this one. B and A are opposite angles of a cyclic quadrilateral. C is the exterior angle. From the theorem, we know B plus A is 180 and B plus C is also 180. That's straight angle. So what can you say about these two? B plus A equals B plus C. B get cancelled out and you get A equals C. This angle is equal to this angle. So from these three examples, what have you noticed? In a cyclic quadrilateral, when one side produced, you get the exterior angle. So exterior angle is equal to the interior opposite angle. So that's another theorem in cyclic quadrilaterals. If one side of a cyclic quadrilateral is produced, the exterior angle formed is equal to the interior opposite angle of the quadrilateral. So here, according to this one, we know that ABCD is a cyclic quadrilateral. BC produced up to E, and what can you say about the proof? Proof will take angles BCD angle plus BAD angle is equal to 180 according to the theorem. Opposite angles are supplementary. Opposite angles are supplementary in cyclic quadrilateral. And also, we know BCD plus DCE 180 according to straight angle. Now we'll take this one and this one. You can equate because both right hand side you get 180. So 1 equals to 2. BCD angle plus BAD angle is equal to BCD plus DCE. But we know BCD get cancelled out. You get BAD angle is equal to DCE angle. So these two are equal. So you can use now this theorem also in questions. Example 1. Find the values of x and y in the cyclic quadrilateral ABCD shown in the figure. Since the opposite angles of a cyclic quadrilateral are supplementary, what can you say about these two? These are opposite angles. 70 plus y is equal to 180, that's supplementary. Take 70 to the other side, 180 minus 70. So what's the value? 110. Now we need to find out x. These two are A angle and C angle, also opposite angles. So opposite angles are supplementary. I can write x plus 2x is equal to 180. 3x becomes 180. So x is 180 divided by 3. You get 60 degrees. So x is 60 and y is 110. Example 2. O is the center of the circle shown in the figure. AB parallel to DC. Find the magnitudes of the angles denoted by symbols. P, T, R. How can we find out the values? Now look at the diagram. O is the center. These two lengths are equal. Radii. OA is equal to OB. Radii. Then what can you say about these two angles? These two angles are equal. This is also P. So how can we find out P? 2P is equal to 180 minus 50. Sum of angles in a triangle is 180. So 130 is 2P. So what is P? 130 divided by 2, you get 65 degrees for P. So this is 65. Then what is the other thing you know already? These two add up to 180. Opposite angles are supplementary, A and C angle. So we can write 75 plus R plus P. P is 65 is equal to 180. Opposite angles are supplementary. So add these two. 140 plus R equals 180. So what's R? 180 minus 140. You get 40 degrees. That's this value. What's the other unknown variable? We need to find out T. Here these two lines are parallel. So what is this and this? These two are allied angles. Allied angles add up to 180. So we know R is 40, P is 65, and you can find T using allied angles. So we can write T plus R plus P is 180 because AB parallel to CD, you get allied angles. Allied angles add up to 180. So what's T? R is 40, P is 65. You get 180. So T plus 105 is equal to 180. So what's T? 180 minus 105. So you get 75 degrees for value of T. Exercise 21.1. Write down all the cyclic quadrilaterals in the figure. We'll start to write down. So you have to first start with a point A. If we start with A, F, E, you can't connect with D. So we can take A, F, D, B. A, F, D, B, A, F, D, B. Can we draw another one? A, F, C you can't take. That's all starting from A. Now start from F. F, E, D, B. F, E, F, E, D, B. Can we draw another one with F? You can't. Now we'll start with D. We can start with D. D, C, B, F. D, C, B, F. We can take another one, but we have already taken that one. D, B, A, F. D, B, A, F. So how many cyclic quadrilaterals we get? 3 cyclic quadrilaterals. Part 2. For each of the cyclic quadrilaterals written above, write down the pairs of opposite angles. We'll first take AFDB, AFDB, AFDB. What are the opposite angles? A angle and D angle, as well as F angle and B angle. Those are opposite angles. Again, the next one, FD, FE, DB, FE, DB, FE, DB, D angle with F angle, D angle with F angle. What's the other one? B with E. And the last one, DCBF, DC, DCBF. So C angle with F angle. What's the other one? D with B. So those are interior opposite angles. Question number 2. Find the magnitude of each of the angle denoted by a symbol based on the information in the figure. O denotes the center of the circle. So this is a cyclic quadrilateral. What can you say about the opposite angles? Opposite angles are supplementary. So these two, 123 plus y equals 180, as well as x plus 50 is equal to 180. So you can find x and y. So what's y? 180 minus 123. What you get? 57. X here is 180 minus 50. You get 130 degrees. So here, why this is 180? You can write down opposite angles are supplementary. Look at second one. That's also cyclic quadrilateral. You can add these two. 5x plus x is equal to 180. So 6x equals 180, x equals 180 divided by 6, you get 30 degrees. Same thing for the other two opposite angles. 2y plus y equals 180, 3y is 180 divided by 3, you get 60 degrees. So all these because of opposite angles are supplementary. Next one. Now these are the two opposite angles. X plus 10 plus 130 is equal to 180. Now solve. 130 plus 130 plus 10, 140. When you take it to the other side, you get x equals 180 minus 140, 40 degrees. These two also opposite angles. So y plus 10 plus 80 equals 180. Y plus 90 is 180. Take 90 to the other side. Y equals 180 minus 90. You get 90 degrees. Look at this one. How can we start? You have given x and y here. What's the relationship between this angle and this angle? According to the theorem, angle subtended at the center is twice as the angle subtended on the circumference. So straight away you can write y equals half of this angle, 230. So 230 divided by 2. You get 115 degrees for y. Now we know y. What's the relationship between x and y? X and y becomes 180. Supplementary. So x plus 115 is 180. What's x? 180 minus 115. 65 degrees. Take the next one. You have three unknowns, x, y, z. And we can see RU is the diameter, passes through the center. What do you know about this angle? This angle is 90 degrees. Semicircle angle is 90 degrees because this is the RU is the diameter. Straight away you can find x. X plus 27 plus 90 equals 180. So x equals 180 minus 90 minus 27. You get 63 degrees for x. And here these two lengths are given equal. So this becomes y. Isosceles triangle. Then RUTS is a cyclic quadrilateral. Look at this side. This is the diameter. RU is the diameter. This is 90 degrees. Now we can find out y. Because opposite angles are supplementary, I can write 34 plus y plus 90 plus y. These two add up to 180. So 2y is equal to 180 minus 90 minus 34. You get 56 degrees. So what is y? Y is divided by 2. 2 times 2, 4. So 28 degrees for y. So we found out y. Now look at this one. How can we find out z angle? Z angle and this triangle, RUT triangle. RUT triangle we'll take. This is 90, this is 34. So what's z angle? 180 minus 90 minus 34. 34. You get 6 here. 56 degrees. So z equals 56 degrees. So x is 63, y 28 and z equals 56. Take this one. What you know? We know this is also passing through the center. AC is the diameter. So we can say this is 90 degrees. This is 90. This whole thing also 90 degrees. These two 90 degrees. And these two sides are equal. So what is one angle? 90 divided by 2. So this is 45. You get this is 45. Then we can straight away from ACD triangle, we can find out y. So what is y? Y plus 90 plus 73 equals 180. Angle sum of a triangle is 180. So what's y? Y equals 180 minus 90 minus 73. We get 17 degrees for y. We found out y angle. Now we'll try to find out x. X angle, you can use either this ABD triangle, or what's the other way we can use? Can we use here? When you look at AD chord, this angle and this angle, same segment angle, same segment angles are equal. So we can write x angle is straight away 73 degrees. Same segment angles. Question number 3. O is the center of the circle shown in the figure. If P equals 60, this is given 60 and S equals 125. S equals 125, then find the magnitude of R and Q. So we know the relationship. This is a cyclic quadrilateral, opposite angles add up to 180. So we know P equals 60. So what's R? 180 minus 60, 120. The other opposite angles S and Q. S and Q equals 180, S equals 125. So what's Q? Subtract 125 from 180. 180 minus 125, you get 55 degrees. Part B, P to R is 2 to 3. P and R. This is 2 to 3 ratio. P and R, the magnitude of P and R. We know the sum is 180. So as a fraction, P is 2/5. 2/5 of the sum, 180. So 5 times 3, 5, 15, 30, that's 6. 36 times 2, 72 degrees. So we need to find out R. What's R? 3/5 of 180. So 5 times 36, 36 times 3, 108. So our angle is 108. Part C. If Q minus S is 120, then find the magnitude of S and Q. Q minus S. The relationship between this and this given, Q minus S is 120. But we know those are opposite angles. What's the sum? Q plus S is 180. So we have two equations, two unknowns, simultaneous equations. We'll solve this. When you add these two, what happens? S get cancelled out. You get 2Q equals 300. Q equals, divide by 2, you get 150 degrees. You can substitute here in one of the equations and find out S angle. So 150 minus S angle is 120. So what's S? S is 150 minus 120, 30 degrees for S. Part D. If 2P equals R, then find the magnitude of P. P and R. So we can write instead of R, that's 2P. This is P. What's the relationship between the opposite angles? Add up to 180. So 2P plus P equals 180. You can find out 3P. 3P equals 180. P equals 180 divided by 3. You get 60 degrees. So they are asking find the magnitude of P. If you are asked to find out R, just multiply this by 2. Part E. If P equals 2x plus y, Q equals x plus y, R equals 60, S equals 90. Then find the values of x and y. We can write down two equations. Opposite angles are supplementary. I can write P angle, that's 2x plus y plus 60 is equal to 180. Then when you take 60 to the other side, 2x plus y equals 120. That's my first equation. Now take the other two opposite angles. X plus y plus 90 equals 180. When you take 90 to the other side, x plus y equals 90. That's my second equation. So when you subtract, y gets cancelled out. 1 minus 2. 2x minus x becomes x. 120 minus 90, you get 30 degrees. Now we found out x, substitute in one of the equations and find out y. We'll take second one. 30 plus y equals 90 degrees. So what's y? 90 minus 30, you get 60 degrees. Question number 4. The points denoted by A, B, C, D, E and F lie on the circumference of the circle with center O. Find the value of FAB plus BCD plus DEF. We'll draw a circle. and mark points A, B, C, D, E, F. And what are the angles? O is the center. Find the value of FAB. FAB. This angle, and BCD. BCD angle we need, and DEF. DEF, this angle. We'll draw a construction there. We'll connect B and E. Now what can you say about, you get AFEB is a cyclic quadrilateral, as well as BEDC, another cyclic quadrilateral. So we need this angle FAB, this angle BCD, BCD angle, this one, and DEF, BCD, this angle, this angle, this angle, and DEF, these two. So we'll try to write down a relationship between angles now. In this AFEB cyclic quadrilateral, we'll take AFEB quadrilateral, cyclic quadrilateral. I'll put this one A, this is E1, E2, this is C, this angle, because we need to find out the relationship between that. So what's the relationship between A and E1? A plus E1 is equal to 180. Opposite angles are supplementary. In this one, BCDE cyclic quadrilateral, what can you say about these two angles? C plus E2 is equal to, again, 180. Opposite angles are supplementary. Now we'll add these two. This is 1, this is 2. 1 plus 2. What do you get? A plus C plus E1 plus E2 equals 180 plus 180, you get 360. What's A? A is FAB angle. What's C? BCD angle. When you add these two, what you get? These two is FED or DEF angle. So what's the sum of DEF? So what's the sum of all three angles? That's equal to 360 degrees. Question number 5. Using the information in the figure, find the magnitude of each of the angles given below. BAE. BAE is this angle. Look at carefully and see. Center is not given. We'll take this one. This cyclic quadrilateral, BAED. BAED cyclic quadrilateral, we know that A angle and 105 both are supplementary, so we can find out BAE angle. So BAE angle is 180 minus 105. So 75 degrees. CBA. CBA. Now we need this angle. This angle. Now we'll take this cyclic quadrilateral. What can you say about this one? AECB, cyclic quadrilateral. Angles are supplementary. B angle with 32 and 27. So we can write B angle is CBA plus 27 plus 32 is 180. So CBA angle is 180 minus the sum. You get 9, 5, 59. So you get 1 there. So 121 degrees for CBA angle. Last one, CBE. Where is CBE angle? CBE. This angle. Which one we can take? CBE angle. So we'll take can we take, yeah, we'll take this one, CBE. We found CBA. This whole thing we found, and previously 75 is BAE. So this is 75. When you take BC chord, same segment angles. This is 27, this is 27. Now we can find out this angle. This means CBE. What's that? CBE. Now we are taking BEDC. BEDC quadrilateral, cyclic quadrilateral. CBE angle is equal to 180 minus sum of the other two angles, 27 and 105. 180 minus 132, you get 48 degrees for CBE angle. Example number 1. In the cyclic quadrilateral shown in the figure, AB equals AD and CB equals CD. Show that ABC triangle and ACD triangles are congruent. So we'll take this diagram. So we need to show these two are congruent. These two are given. This side is given to this side. This side is given to this side. So we can easily show that these two are congruent. ABC triangle and ACD triangle. AB equals AD, that's given. BC is equal to CD, that's given. AC is common. So all three sides, corresponding sides are equal. So therefore, ABC triangle is congruent to ACD triangle. What's the situation? Case side, side, side. Then part 2, deduce that AC is the diameter. We know that these two triangles are congruent, corresponding elements are equal. So what are the corresponding elements? If you take AC, opposite to this one is this one and this one. So we can write B angle is equal to D angle, corresponding elements. Those are equal, corresponding elements are equal. But we know when you take ABCD cyclic quadrilateral, B plus D is 180 supplementary. So we can write 2B equals 180, B angle is 90 degrees as well as D angle is 90 degrees. So if this is the diameter, you get semicircle angles are 90 degrees. So we can write therefore AC is a diameter. So AC is the diameter. Why? Semicircle angles are 90 degrees. Example number 2. In the parallelogram ABCD, AB produced to E such that CB is equal to CE. Show that AECD is a cyclic quadrilateral. Let's take BEC triangle. These two sides are equal. BC equals EC. What can you say about this angle and this angle? A angle should be equal to B angle. Isosceles triangle. Then what else we can say? D and C. What can you say about D and C? D and C are equal. Opposite angles of a parallelogram. Now we need to show A and B is equal to, the sum of A and B is equal to 180. So what's the relationship between these two? C plus A equals 180 because of straight angle. Instead of C, I can put D. Instead of A, I can put B. D plus B is 180. So these are opposite angles of a cyclic quadrilateral. So opposite angles are supplementary, means this is a cyclic quadrilateral according to the converse theorem. So D plus B is equal to 180. You can write down opposite angles. Opposite angles are supplementary. So therefore, AECD is a cyclic quadrilateral. Exercise 21.2. State with reasons whether each of the following quadrilaterals is a cyclic quadrilateral or not. Quadrilateral ABCD. We'll find out the angle A. What's the angle A? 180 minus 52. 128 degrees. We'll find out C angle. 180 minus 128. You get 52. What can you say about these two? If it's a quadrilateral, cyclic quadrilateral, these are opposite angles. So we'll see what's the sum of A and C. 128 and 52, you get 180. So opposite angles are supplementary. So therefore, ABCD is a cyclic quadrilateral. Now take the next one. Quadrilateral PQRS. PQRS. Look at PSR triangle. This one is 35, so this is also 35. Why? Isosceles triangle. If this is 35, so what's S angle? We'll find out S angle. 180 minus 35, you get 70. So 180 minus 70 is 110 because of isosceles triangle. Then what about Q angle? Q angle is 180 minus 110. That's 70 because of straight angle. Now add and see S and Q. S plus Q is 110 plus 70. You get 180. So therefore, PQRS is a cyclic quadrilateral. Next part, quadrilateral FGDE. FG, identify that one. FGDE, this one. Look at this angle, G angle, this G angle. What can you say about G angle? G angle is the exterior angle to these two angles, GCD triangle. So G angle you can write 30 plus 40, that's 70. Exterior angle. Exterior angle is equal to the sum of opposite angles. What can you say about this angle, E angle? Look at ABE triangle. So E angle is also equal to 70 plus 40. Same reason. You get 110 because of exterior angle. Then when you add G and E, what you get? 70 plus 110, you get 180. Opposite angles are supplementary. Therefore, FGDE is a cyclic quadrilateral. Look at this one. You have given two parallel lines, quadrilateral QRML. QRML is this one. Now, according to parallel lines, if this is A, this is A. And another information given, PQ is equal to PR. That means this is also A because isosceles triangle. If this is A, this is also A. So first we'll write down Q angle is equal to R angle because of isosceles triangle. Then this is A, P, L, M angle and P, M, L angle both are A because of parallel lines, alternate angles. Now we can find out the opposite angles. So this is 180 minus A. So M is 180 minus A. So we'll add and see Q plus M angle. Q plus M is, Q is A angle plus 180 minus A. A get cancelled out, you get 180. So opposite angles are supplementary. So therefore, QRML is a cyclic quadrilateral. Question number 2. Show that PQRS is a cyclic quadrilateral if P equals Q and R equals S. So we'll take any quadrilateral PQRS. P equals Q. We'll put A here, R and S. We'll put B. Now we know this is a quadrilateral. What's the sum of angles in a quadrilateral? 360. A plus B is 360. 2A plus 2B equals 360. Divide everything by 2. A plus B equals 180. A plus B means opposite angles. So opposite angles are supplementary. Therefore, PQRS is a cyclic quadrilateral. You can write down this is sum of angles in a quadrilateral. Question number 3. In the cyclic quadrilateral ABCD, AC is joined. Show that BAC is equal to ADC minus ACB. ABCD. BAC. AC joined. BAC is this angle. ADC. ADC is this angle. ACB. This angle. So we need to find out the relationship between these three angles. Now we'll take, this is a cyclic quadrilateral. Opposite angles add up to 180. So we'll put A here. This is B. This is C. So you need to prove that A equals ADC is C minus B. That's what you need to prove. We'll find out this angle using A and B. What's that angle? B angle is equal to 180 minus A plus B. Then what's C angle? C and B angles are 180. So C angle, C plus 180 minus A plus B, that's equal to 180. These two add up to 180. So what we can say, 180 get cancelled out. We get C minus A minus B equals 0. So what is A? I'll take it to the other side. A becomes C minus B. So we can see A equals C minus B. So we can write down the reason here why this is this one. Sum of angles in a triangle. This one is because opposite angles are supplementary. So we can write without writing C minus B. Now we'll write down proper angles. So A equals, A means BAC angle is equal to ADC is C angle minus ACB angle. Question number 4. Show that A, B, C and D are points on the same circle. If ABD plus ADB is equal to ACB in the quadrilateral ABCD. ABCD. ABD. So we need to connect this one because this is ABD. ADB. We'll put this one A, this is ADB. This is B. DCB. DCB is, this is, we'll put C. Now we need to find out the relationship A plus B is equal to C. So we need to show this is a cyclic quadrilateral. So we'll find out this angle first. A angle. A angle plus C. C value is 180. But we know A plus B plus A angle is also 180. So we can write this is opposite angles are supplementary. And this is sum of angles in a triangle. Now we'll subtract these two. 1 minus 2. We get A plus C minus A minus B minus A is equal to 180. 180 0. AA get cancelled out. You get the relationship. What's the relationship? I can take A and B to the other side. A plus B equals C. So what is C means? BCD. BCD or DCB. DCB angle is equal to A means ABD angle. ABD angle plus B angle is ADB. So these two add up to the other angle. Question number 5. Using the information in the figure, prove that CDFE is a cyclic quadrilateral. CDFE. Identify. CDFE. These two are, this is a cyclic quadrilateral. We'll put angles and see. This angle and this angle, same segment angles. I'll put A here. So this is also A. Same segment angles are equal. And these two lines are parallel. This and this. So what is this angle is A. So we get opposite angles are supplementary. So we can write down BAE angle is same as AEF angle. AEF angle because of alternate angles. And also we know CDF angle is same as BAE angle because of same segment angles. Now these two are equal. So therefore, what is this angle? CEF angle. CEF angle is 180 minus A. And D angle is A. So we'll find out the sum of opposite angles. CEF angle plus CDF angle. What's the sum? CEF is 180 minus A. CDF angle is A. Minus A plus A get cancelled out. You get 180. That means opposite angles are supplementary. So therefore, CDFE is a cyclic quadrilateral. Question number 6. If AB is a diameter of the circle in the figure, show that APB is this angle, CAB is this angle, ABC is this angle. So we need to identify the relationship between these three angles. So this is a diameter. We'll put separate letters. We'll put this one A, B, C, D. We know this is diameter. If this is diameter, this is 90, this is 90. So what's the relationship between ABC? From ABE triangle, I can write A plus B plus C plus 90 is 180. Sum of angles in a triangle. So what is A plus B plus C? I get 90. What's the relationship here? Again, A plus. I can write A plus C plus D is also 90. When you take ADB triangle, A plus C plus D is also 90 degrees. 1 and 2 both are equal. We can say A plus B plus C is same as A plus C plus D. A get cancelled out and C get cancelled out. B equals D. And that's also, we can easily get it from same segment angles. Same segment angles are equal. So what can you say about P angle? We need the relationship between APB. APB is, this angle is equal to CAB is A plus B. What is ABC? ABC is C plus D. So we need to find out A plus B plus C plus D is equal to APB. What's this angle? If you know this is D and this is 90, what's this angle? 90 plus D or B. I'll write down the same angle. 90 plus B is P angle. So we'll write it down. APB angle is equal to 90 plus D, or we can write 90 plus B. I'll change this one to B now. This is also B. Because this angle is equal to this angle. Now, how can I write 90? 90 is A plus B plus C. A plus B plus C, and I'll take D here because here according to the previous one it's A, B, C, D. So we can straight away write down what's A plus B means. Instead of this, I can write APB is equal to, instead of A plus B, I can write CAB and C plus D. C plus D is the B angle, ABC angle. Question number 7. In the triangle PQR, PQ is produced to S. PQR. PQ is produced to S and PR is produced to T. The bisectors of SQR. Bisector, it means this is X, this is X. Same angles, bisector of this and PQR. QRT here. If this is Y, this is Y. These two bisectors meet at X. PQR bisector and PRQ bisector meet at Y. This one and this one meet at point Y. So I'll Mark this also. This angle is equal to this angle. This angle is equal to this angle. Show that QXRY. QXRY is a cyclic quadrilateral with XY as the diameter of the corresponding circle. So you have to find out this is a cyclic quadrilateral as well as XY is the diameter. Now we'll put letters here A. This is B. What can you say about this angle? 2x plus 2a is 180. So when you divide by 2, a plus x is 100. A plus x is 90 degrees. This side, I can write 2b plus 2y is also 180. So b plus y equals 90 degrees. So what is b plus y? What is a plus x? The opposite angles. This angle and this angle both are opposite angles. So opposite angles, we'll add and see 1 plus 2. You get a plus b plus x plus y equals 180. So this is a plus x is y qx angle and b plus y is y r x angle. So opposite angles are supplementary. So that means QXRY is a cyclic quadrilateral. Now we have to find out this is diameter. How can we show this is diameter? We need to say these two are equal. Then only you get 90 degree each. How can we show that this is 90 degree? A plus x, here already it's there. A plus x is 90, b plus y is 90. Semicircle angles 90 means a xy is a diameter. So we can write from 1 and 2. Semicircle angles are 90 degrees. Therefore, xy is a diameter. Now the last part, part 2, find the magnitude of QXR. QXR, this angle, if QPR is 40. QPR is 40 degrees. This is 40 degrees. Find the magnitude of QXR. QXR. Here we need to find out this angle. If this is 40, if you take the PQR triangle, what can you say about PQR triangle? PQR triangle, 2A plus 2B, 2A plus 2B plus 40 equals 180. So when you take 40 to this side, you get 140 here. What's A plus B? A plus B equals 70 degrees. A plus B is 70. If this is 70, what is Y angle? Y angle is 180 minus A plus B. So, Y angle is 180 minus A plus B. That's 180 minus 70 degrees, you get 110 degrees. So, now we know this is 110. So, what's QXR angle? QXR angle is 180 minus 110 because opposite angles of a cyclic quadrilateral is 180. So, you get 70 degrees. So, here we can write this is because of supplementary. Question number 8. The two circles in the figure intersects at x and y. A straight line drawn through x meets the two circles at A and B. If D and C are marked on the circle such that AD is parallel to BC. So, this is parallel to this line. Show that DYC is a straight line. So, we are not sure DYC is a straight line. So, you can't connect at once. So, DY will connect first and YC will connect. Now, we have to show that these two are, this is a straight line. So, straight line means this angles add up to 180. So, I'll first connect x and y. We can see AXYD is a cyclic quadrilateral. AXYD, cyclic quadrilateral. So, we'll put this is A. If this is A, this is I'll put that one B and XYD as A. We know that A plus B is 180. But these two lines are parallel. What can I say about this angle? This is 180 minus B, or I'll put this one as C and this one as D. What's the relationship between B and C? B plus C is 180. Allied angles, because AD is parallel to BC. Now we'll look at other quadrilateral, XYCB, cyclic quadrilateral. What can I say about this angle? I'll put this one as E. E plus C is 180 because of cyclic quadrilateral. Now, we need A plus E. Now, when you subtract 1 and 2, when you subtract 1 and 2, what you get? 1 minus 2. A plus B minus B minus C equals 0. So, B get cancelled out. We can see A equals C. Now, instead of C, I can put A in the third equation. Take the third equation. E plus A equals 180. A plus E means straight angle. You are getting straight angle. So therefore, straight angle is 180. So therefore, DYC is a straight line. Example number 1. Find the values of A and B based on the information in the given figure. These two lengths are equal. So if these two are equal, we can write this also B. Isosceles triangle. And what's the theorem? Says exterior angle is equal to opposite interior angle. So straight away you can write down A equals 100, exterior angle is equal to interior opposite angle. Now we need to find out B. Take ABD triangle. A is 100. So 2B plus 100 equals 180. 2B equals 180 minus 100, that's 80. Divide by 2, you get B equals 40 degrees. Example number 2, find the values of x, y, z, m and n based on the information in the given figure. ADCB is a cyclic quadrilateral. This is exterior angle is 120, that's equal to interior opposite angle. So C plus 65 is 120. So what is Z? 120 minus 65, you get 55 degrees. Now can you see, if you take BC chord, same segment angles, this angle is equal to this angle. So Z and Y both are equal. So Z plus Z and Y both 55. Same segment angles. Now we found out this is 55, this is 55. Now we can find out N. Look at this exterior angle. This exterior angle is same as this angle. So we can find out N plus 55 is equal to 80. So N equals 80 minus 55. 25 degrees. So we found out this is 25. Now we need to find out this one, M. M we can find out using ABD triangle. ABD triangle, M plus 55 plus 65 plus 25 is all equal to 180. That's a triangle. So what's M? What's the value? You get 145 equals 180. So what's M? 180 minus 145, 35 degrees. That's M. This is 35. Then you can find out x. What's x? This is a straight angle. X is equal to 180 minus 80 plus 35. 180 minus 115. So you get x as 65 degrees. So we found all x, m, y, z, n. Example number 3. The two circles in the given figure intersect at A and B. Moreover, PA equals PB. This is already given. If APB is 70 degrees, find the magnitude of ARQ. ARQ is this one. We can find out using this information. Now, APB is an isosceles triangle. So, what's this angle? This angle is, we'll write PBA angle is 180 minus 70 divided by 2. 110 divided by 2, that's one angle is 55. So, this is 55. So, what's this angle then? ABQ angle is 180 minus 55. 125 degrees. This is 125. So, what's PRQ angle? PRQ angle is 180 minus 125, because in a cyclic quadrilateral, opposite angles are supplementary. .55 degrees. Is AB parallel to RQ? You draw a line and see. AB parallel to RQ. So, we'll see this is 55. And this is also we found 55. Alternate corresponding angles are equal. AB and RQ are parallel. So, we can say PAB angle and PAB angle is same as ARQ angle or QRA, that's 55 degrees. Corresponding angles are equal. Therefore, AB is parallel to QR. Exercise 21.3. By considering the figure, name an angle equal to each of the angles given below. CBP. CBP, this angle. That's the exterior angle. So, what's exterior angle is equal to the interior opposite angle, this one. AEC. AEC. Then Part 2. DCQ. DCQ. This is this exterior angle. So this exterior angle is same as this angle. AED. REA. REA. This exterior angle is same as this angle, opposite interior angle, ABC. SEA. SEA. This angle. This angle is same as this angle, ACD. EAT. EAT. This exterior angle is opposite interior angle is this, CDE. Question number 2. In each of the circles given below, the center is O. Find the magnitude of each of the angles denoted by an algebraic symbols. Look at carefully. This is a cyclic quadrilateral. To this one, this is the interior opposite angle. So what's x? X is 70. To this angle, this is the opposite interior angle. Y equals 100. Exterior angle is equal to opposite interior angle. This question. 84 is the exterior angle. This is same as x. So x equals 84. You can write down the reason. I'll write just exterior angle. Then we need t. This is a straight line. T is 180 minus x. That's 84. You get 96 degrees. And if you take this angle and this angle, those are equal. Exterior angle and opposite interior angle. So T equals same as y. So this is y also 96 degrees. Next part. What's x? Look at carefully. To this chord, this is the angle subtended at the center. Here angle subtended on the circumference. So what is x? Straight away we can write down 30 times 2. Then, is this a cyclic quadrilateral? No, you can't just write y equals x. Y is the cyclic quadrilateral to this one, to this diagram. So what's y? Y is same as 30. So x is 60, y equals 30. So this is exterior angle. And here I can write down, this is according to the theorem, angle subtended at the center. This one, part 4. This is 30, this is 30 because two sides are equal. Then you can find out this angle. What's this angle? 180 minus 60. You get 120. So this angle is same as x. Exterior angle is equal to opposite interior angle. So x equals 120. This one, this is 40. So what's this angle? One angle you can write down 180 minus 40 divide by 2. I'll put this one as y. That's y angle. 180 minus 40 is 140 divided by 2, 70 degrees. So this is 70, this is 70. So what's this angle? This angle is 180 minus 70, you get 110. This angle and this angle both are equal because exterior angle is equal to opposite interior angle. That's 110. This one, two parallel lines given. So if this is 63, what's this angle? This angle is 180 minus 63. That's 117 because of allied angles, add up to 180 because the two lines are parallel. Then what's x? X is same as that because of exterior angle and the interior opposite angle. This one, same segment angles. Look at this one. This angle and this angle. If this is 30, this is also 30. Then you can find out x using sum of interior angles is equal to the exterior angle. So 30 plus 42, that's 72 degrees. Sum of interior angles. This diagram. If this is x, this is also x. Same segment angles are equal. Now, this and this, same. Exterior angle is equal to the interior opposite angle. So, 60 plus x equals 80. X equals 80 minus 60. You get 20 degrees. This one, O is the center. We can find out this angle. This is 62, so this is 62. Same segment angles are equal. And we can find out this angle is 30. Same segment angles are equal. And if this is 105, what's this angle? We can find out this angle because exterior angle is same as the opposite interior angle. So this angle is 105. So what's this angle? This angle is 105 minus 62. 43 degrees. Now we can find out x angle. So x plus 43 plus 30 is 180. When you take this triangle, so x is 180 minus these two, 73. You get 107 degrees for x angle. Take the next one. This is x, means this whole thing is x. Exterior angle is the same as opposite interior angle. And this one, 30, this is parallel to this one. So this angle, what's this angle? X minus 33 is same as, this is also x minus 33. Because the whole thing is x, the other one is 33. So 33, x minus 33. Now, what's the relationship? These two add up to 180, opposite angles of a cyclic quadrilateral. 87 plus x minus 33 equals 180. So x plus, you subtract these two, 54 equals 180, x equals 180 minus 54, 126 degrees. Now there's an easy way also to do this. If this is 87, what's this angle? 180 minus 87. 180 minus 87 is 93. This is 93. That means this is also 93. So what is x? X equals 93 plus 33. 126. This one. This is radius, so this is equal to this one, and this is also equal. All three are radii. This is x, this is x, and here 120 is there. So 180 minus 120, you get 60. 60 divided by 2, 30, 30. Now, what's the relationship between with this exterior angle? X plus 30. X plus 30 is equal to 70 degrees. So what's x? 70 minus 30, that's 40 degrees. This one. These two lengths are equal. So what is this one? These two, 180 minus 130, you get 50. 50 divided by 2, 25 each. And can you see the relationship between Q and 70? Q is equal to 70. Exterior angle is same as interior opposite angle. So this is 70. And how can we find out P? Look at carefully. This is also cyclic quadrilateral. This is 130. So what is R? R is 180 minus 130. Opposite angles are supplementary. So R equals 50. What's P angle? Now we found out this is 50. Now we can find out the P angle. Sum of angles in a triangle is 180. P plus 70 plus 50 equals 180. P plus 120 is 180. So what's P? 60 degrees. 180 minus 120. Question number 3. The points D, E and F are on the sides BC, CA and AB respectively of the triangle ABC such that BDGF, BDGF and DCEG are cyclic quadrilaterals. These two are cyclic. So this one and this one given as cyclic quadrilaterals. Furthermore, GDC is 80 degrees. Find the magnitudes of AFG. So you are asked to find out this angle AFG, AEG, this and this. So we can find out easily. Look at carefully. This is the exterior angle to this cyclic quadrilateral. F, B, D, G, F cyclic quadrilateral. We can find out this angle is BFG angle is 80 degrees because of exterior angle is same as exterior angle is same as opposite interior angle. Then what is AFG angle? AFG angle is 180 minus 80, that's 100 degrees. Now we look at the other side. If this is 80, what is GEC angle? GEC angle is 180 minus 80, that's 100 degrees because sum of angles, opposite angles are supplementary. This 100. So what is AEG angle? AEG angle is 180 minus 100, you get 80 degrees. So those are the two angles. Show that AFGE is a cyclic quadrilateral. Now we found out this angle is 100, this angle is 80. Now those are the opposite angles of a cyclic quadrilateral. So what can you say? Opposite angles add up to 180. So we can write down, if this is 1 and 2, 1 plus 2, you get GEC plus AEG angle is 180. Opposite angles are supplementary. That means AFGE is a cyclic quadrilateral. Question number 4. The circles given in the figure intersects at P and Q. The straight lines APB and CQD meet the circles at L, P, M and X, Q, Y respectively. Find the magnitude of BMY. BMY, this angle. If ALX ALX is given 105. Now we'll do using this cyclic quadrilateral. If this is 105, what's this angle? 105. Exterior angle is equal to opposite interior angle. If this is 105, what is this one? That's also 105. To this cyclic quadrilateral, then straight away we can find out the other angle. So I'll write down XQP angle and PMY angle, both are 105 because of exterior angle is same as interior opposite angle. Then what's BMY angle? 180 minus 105. 75 degrees. Then the next part, show that LX and MY are parallel. We can see that straight away. This angle is same as this angle. Those are corresponding angles. Corresponding angles are equal means LX and MY both are parallel. So we can say ALX angle is equal to PMY angle, that's 105. Corresponding angles are equal. Corresponding angles are equal means LX is parallel to MY. Question number 5. The center of the given circle is O, the diameter AB and the chord PR intersects perpendicularly at L. The line segment QR and AB intersects at T. If QTA is X, this is X. Write in terms of X the magnitude of LRT. LRT, this angle. If this is X, this is X. This is 90 degrees. So what's LRT angle? LRT angle is 90 minus X. So we can write LRT is equal to 90 minus X because sum of angles in a triangle is 180. Then the magnitude of OPQ. OPQ. So we need to connect that. OPQ. That's the radius. We'll connect this one also. This is equal to this one. Now we need to find out OPQ. OPQ angle, this angle. First we'll find out this angle. This angle. What's this one? Look at carefully. PQ is the chord. So this is the angle subtended at the center. So what's the angle subtended on the circumference? That's our angle. So we can write QOP angle is double of LRT angle. That's 90 minus x. So you get 180 minus 2x. So you can write down according to the theorem. That's this one. Then when you take PQO triangle, OQ and OP both are radii. So what is QPO angle? QPO angle is 180 minus this angle and divide by 2. 180 minus this angle divide by 2. So when you simplify, what you get? 180 minus 180 plus 2x divided by 2. 180 you get cancel out. 2x divided by 2, that's x. So we found out this is x. So these are the two angles. Now part B, show that QTOP, this one is a cyclic quadrilateral. Now look at carefully. This is exterior angle, this is opposite interior angle. Both are equal. So you can write down QTA is equal to OPQ angle, OPQ, that's x. So we can write down QTOP is a cyclic quadrilateral. Because exterior angle is same as interior opposite angle. Question number 6. In the figure, PQ is equal to QR and PR is equal to PS. If PRS is 2 QRP, PRS is 2 QRP. If this is X, QRP is X, then PRS is 2X. Show that PSRQ is a cyclic quadrilateral. Now, if this is 2x, this is 2x, isosceles triangle. If this is x, this is x. Then you are asked to show that PSRQ is a cyclic quadrilateral. Now what's this one? From this triangle I can find out this angle is 180 minus 2x becomes 4x. Now we'll see opposite angles P and R. So what's P? X plus 180 minus 4x. What's Q? What's R? R is 3x. Add these two. 1 plus 2, P and R equals x minus 4x plus 180 plus 3x. X minus 4x minus 3x and plus 3x get cancelled out. You get 180. So that means opposite angles are supplementary. Therefore, PSRQ is a cyclic quadrilateral. So here you can write down because of isosceles triangle. Second part, QPT. QPT. This angle to PRS. PRS is 2x. Now what is this angle? If this is a cyclic quadrilateral, this becomes 3x. This angle and this angle both are equal. So I can write, this is part 2, QPT angle is 3x. That means exterior angle is equal to interior opposite angle. And we need PRS. PRS is 2x. So what's the ratio? QPT over PRS is equal to QPT is 3x, PRS is 2x, x get cancelled out, 3 over 2 means what's the ratio? QPT to PRS angle is 3 to 2. So that's what we need to show. Question number 7. PQ is equal to QR in the cyclic quadrilateral PQRS. Moreover, PS is produced to T such that RS is equal to ST. If SRT is 32, find the magnitude of QRP. QRP is this angle. If this is 32, this is 32, isosceles triangle, then you can find out this angle. What is S angle? Our ST angle is 180 minus 32 and 32 becomes 64. 116. So this is 116 means this is also 116. So what's PRQ or QRP angle is 180 minus 116 divided by 2 because this is an isosceles triangle. You get 32 degrees for the first part. Second part, show that QS and RT are parallel. These two are parallel. How can we show these two are parallel? Here we found out QRP angle is 32. If this is 32, what's this angle? This is also 32. Same segment angles are equal. So I can write PSQ angle is also 32. Same segment angles. Then PSQ and STR, both are 32 degrees. Those are corresponding angles. Corresponding angles are equal. So therefore, SQ or QS is parallel to RT. In this section, we covered 3 theorems related to circles and cyclic quadrilaterals. Remember those 3 theorems and apply in exercises and examples.